Okay, so now let's see the last example in this section. We want to find the absolute maxima and the absolute minima of the function f. And the function f is defined by this way: x squared subtract 2xy plus 2y. Yeah, and on the range, on the region and region s between 0 and 3, and the region is 0, 3 times 0, 2. This region. Okay, so it's easy to see its continuous function. Its continuous function, x for the variable x and for the variable y, of them are the polynomial, so it's easy to see. Its continuous function on the closed and the bounded region, then it must have the absolute maxima and absolute minima. Okay, and how to check the absolute maxima and the absolute minima? As we say, we should check the function f on its boundary on its boundary part. I mean, actually for this one is the graph. This one. We should check the function f on the state. Here is 0, 3, so it's 0, 3 here, 0, 2. Yeah, probably is this one. Yeah, so it's 3 is 2. So you should consider all the boundary. It means that you should consider the function f on the point, on all the points on this line, and this line. Okay, yeah, and we also need to check inside. Inside, you should consider its critical point. It means that you should consider its partial derivative, its partial derivative by x and partial derivative by y, and let it be 0 simultaneously. And otherwise, you should consider its partial derivative does not exist. The points such that its partial derivative does not exist. Okay. So first of all, we should consider its partial derivative. That's why we say in chapter 11. Almost all questions. First of all, you should consider its partial derivative. Okay. So first of all, you should consider its partial derivative. So its partial derivative by x is now the derivative. Consider its derivative by x, then the variable, we could view the variable y as a constant. So this part is 2x. Y is a constant, so keep 2y. So x is derivative 1, so subtract 2y times 1, so it's this one. And vy is a constant, so its derivative is 0, so just this 10. And f sub y. Now the variable y, then view x as a constant. So constant is derivative 0. And this one, negative 2x is constant. Y is derivative 1, so subtract 2x. And this one is derivative plus 2. Right? And actually, in this case, you could see that we should consider critical point and the function f on the boundary. But for its critical point, we should consider its critical point f or PQ. And the PQ is the critical point. Critical point of f is the critical point of f. But when we say critical point of f, what's the definition? Its definition is this one. First one is that simultaneously these two equation holds. Otherwise, one of f sub x PQ or one of s sub x or s sub y, one of them does not exist. But as you see, it's polynomial. Form. For you can see its derivative, it must exist, right? This form, for any xy, it must exist. So when we consider its critical point, we don't have these cases. We just have this case, right? When we consider critical point, just have this case. And the issue holds simultaneously. Right? When we consider critical point, these two equations should hold simultaneously. And for first one, move it to right hand side, you will get 2x equals 2y. and divide by 2, x equals y. And then this one, move it to right hand side, you get 2x equals 2. Divide by 2, you get x equals 1. Right? So finally, you will get x equals y equals 1. X equals y equals 1. So we just have the, so we have the point 0, 0. We have the point 0. So you should consider f of 0, 0 its value. And sorry, it's 1, 1. Sorry, I'm wrong. Yeah. So it's 1, 1. So you should consider f of 1, 1. And the f of 1, 1 is 1 subtract 2 plus 2. So finally it's equal to 1 in this case. So it's the first case you should consider. It's the first case you should consider. Critical point. Critical point. It's inside case. It's inside case. Inside you should consider critical point. Inside you should consider critical point. The reason is that when we say critical point, we won't talk about the boundary, the case on its boundary. Yeah, so inside you should consider critical point. Outside you should consider, not outside, beside the critical point, you also need to consider the boundary case. So now let's see the boundary case. So for its boundary case, we have several lines. So first one we denote by L1. Here is our L1. And this one is our L2. And this one is our L3. And the last one is our L4. So let's see each case. First, next one is L1. So all the points in L1, its x coordinate must be 0, right? X coordinate must be 0. So it's x0 equals 0. But y between 0 and 2. So L1 is the line. And then we should consider f of xy, the function f on this line, its maxima and its minima. So we should consider f of 0, power in the value 0, y. So f of 0, y. So now s equals 0. So it's 0 subtract 0 plus 2y. So it's the function 2y. And then the function 2y, when we between 0 and 2, we should know its maxima and minima, and to discuss its largest value and the smallest value. So we should consider f of, just a case, 0 and 2, right? So it's f of 0, 0, and f of 2, 0, 2. F of 0, 2. So f of 0, 0 is 0. And f of 0, 2 is 2 times 2 is 4. This one. So in this line, in L1, its minimum is 0, and then the maximum is 4. Okay, so later we should discuss all of them to figure out which one is the smallest one, which one is the largest one. And this is a case on L1. And now next one we consider L2. And L2, all the point on L2 is x coordinate equals 3. So it's a case when x equals 3. And the y still between 0 and 2. And we still plug in the value 3y. So it's f of 3y. So now plug in the value 3 for the value x. We plug in the value. For the variable x, we plug in the value 3. So it's 3 squared, so it's 9. Subtract 3, 2 times 3 is 6. Times y plus 2y. So it's equal to 9 subtract 4y. Okay, so now it becomes one single. Actually, for this one or this one, it becomes one single variable function. One single variable function and the y between 0 and 2. How to find its absolute maxima and absolute minima? It's also the question in section 4.1. Single variable function, how to, if its it's easy to see this function. Its variable is y and it's continuous. Continuous function on the corresponding interval, it must have the absolute maxima and absolute minima. And how to check it? Of course, you should check the endpoint. Plug in the value 0 and plug in the value 2. But you also need to consider inside its critical number. I mean, you should consider its derivative and consider its derivative. Let its derivative be 0 or does not exist, right? So, but in this case, if you consider its derivative, 9 subtract 4y its derivative is equal to -4. It means that it's always non-zero. So for this function, it doesn't have the critical number. Because when we say critical number, it should be 0. But its derivative equals -4 for any y. So for any y, it's not the critical number. It's not a critical number. So we just need to consider boundary case. So you just need to consider boundary case f of 3, 0 and f of 3, 2. Just need to consider these two cases. And this case is 9 subtract 4 times 0, so it's 9. Subtract 0, so it's 9. This case is 9. And this case is 9 subtract 4 times 2, so it's 8. So it's equal to 1. Okay? So it's the third case. On L2. Now let's see the case on L3. On L3, then on L3, all the point on L3 its y coordinate is 0. Since it's on x-axis, so y coordinate is 0. So y equals 0. And the x between 0 and 3. X between 0 and 3. This one. And here, now let's plug in the value f of x0. So it becomes f of x0, so it becomes plug in the value y, plug in the value 0 for the variable y. So it's s squared subtract 2x times 0, so it's 0. 2 times 0 is 0, so just s squared. And the s between 0 and 3. So it's easy to see. Otherwise, you also could explain by this way. I mean, it's continuous function on closed and bounded interval. It must have the absolute maxima, absolute maxima, and absolute minimum. And how to check it? Check endpoint. F of g. Check the endpoint. Let s be 0 and let s be 3. And you also need to check its critical number. Critical number, you should consider its derivative and let it be 0. And its derivative is 2s. And let it be 0, then s equals 0. But it's exactly in the boundary case. So you just need to consider the boundary case. So f of 0, 0 and f of 3, 0. You just need to consider boundary case. Okay? Yeah. Originally you should consider f prime as 0, so it's equal to 2x, and let it be 0. Then you could get s equals 0. But s equals 0 is just the boundary case. It's just the boundary case. Here. For x squared, let it be. Consider its derivative is equal to 2x. Okay, so this part, let me see. It will be better to explain by this way. I mean, x squared, consider its derivative is equal to 2x, and let it be 0, you will get s equals 0, this one. Okay, anyway, so f of 0, 0 is 0. F of 3, 0 is 3 squared, so it's 9. So we have these 2 points. These two values. Okay, so the last one, L4. So on L4, on the line L4, all the y coordinate value is equal to 2. So y equals 2. And the x between 0 and 3 is a line. And so you plug in the value 2 for the variable y. So it's f of x2 is equal to x squared subtract 2 times 2x times y, now y is 2, so 2x times 2, so it's 4x. 4x plus 2y, so plus 2 times 2, 4. Plus 4, plus 4. Yeah, so for this one, use the same argument, you could see that, consider the first one, of course you should consider the boundary case. And you also need to consider, okay, boundary case is f of 3, 2, f of 0, 2. We start from 0. So f of 0, 2 is equal to 0 subtract 0 plus 4, so it's 4. And another one is f of 3, 2. Boundary case, f of 3, 2 is 3 squared is 9. Subtract 4 times 3 is 12. Plus 4. Plus 4. So it's 9 plus 4 is 13. Subtract 12, so it's 1. It's 1. And another thing is that it's still a continuous function on closed and bounded interval. I mean, it must have the absolute maxima and absolute minima. And how to check the endpoint 0 and 3. And then you also need to check its critical number. So in other words, you should consider its derivative. So you should consider its derivative. S squared subtract 4x plus 4. This function is derivative. And its derivative is 2x subtract 4. So let it be 0. Let it be 0. You will get x equals 2. And the value x equals 2 is between 0 and 3. It's between 0 and 3. So indeed, you should check this point when x equals 2. So you should check f22. Indeed, you should check f22. And the f22 is equal to 2 squared subtract 4 times 2, 8. So it's 4 subtract 8 plus 4. So it's 4 subtract 8 plus 4. So what's the number? 4 subtract 8 plus 4 is equal to 0. It's equal to 0. Right? It's equal to 0. So indeed, you should consider this case, and this case. And you will see, actually 0 is the minimum in this on this line, L4. 0 is the absolute max minimum. Absolute minimum. Yeah. And for this special case, yeah, originally we should consider it by this way for each situation. But for this one, it's special case. I mean, for this one, you consider it's equal to s subtract 2 is squared. Indeed. So for this question, of course, for this question, you also could explain it by this way. It's equal to this 10. So of course, when s equals 2, it's the minimum. Its value is 0. Because it's of the form, so this value, it must be positive. It must be greater than or equal to 0. So when s equals 2, it must be the minimum. When s equals 2, it must be a minimum. Its value is 0. Okay. Yeah, so final step is to check which one is the absolute maximum and the absolute maximum, and which one is the absolute minimum. So now we should check each of them. So first one is this one, the case. When we look at the critical point is this one. 1, 1, then the value is 1. And second one is 0, 4. So it's 1, 0, 4, 9, 4. 0, 9, 4, 1, 0. So you could see 0 is the 0, this case, 0 is the smallest one. 0 is the smallest one, and 0, which one? 0 is the smallest one, right? So the absolute absolute minimum is f of the value is the value f of 0, 0. If we say absolute minimum, it should be the value, but it had two cases, f of 0, 0 and f of 2, 2. So f of 0 equals 0, f of 2, 2 equals 0, and both of them are, and 0 we call it absolute minimum. Absolute minimum. And absolute maximum, here is the value 1, 4, 9, 9, 1, 4. So of course 9 is the maximum. Here 9 is the maximum. Where 9 here 9 is the maximum. Yeah, so it's a case 3, 0. So f of 3, 0 is equal to 9, and it's the absolute maximum. Absolute maximum. Yeah, absolute maximum. Let me check it. Yeah, absolute maximum is 9, absolute minimum is 0, and it has 2 cases. Yeah. Okay, so that's all. That's all the result in section 11.7. Section 11.7. So for the material in chapter 11, we have already introduced them. Yeah, yeah, and yeah. So next time later we will consider the material in chapter 12. In chapter 12.